Hi, this is Group 7 and we're doing combinations of functions, starring...
I'm Alex Mono.
I'm Thomas Bold.
I'm Shina Swan.
And I'm Zach Harvey. Let's do some trig. In the objective of the combination of functions, we are trying to get this form, y equals little a sine big B of x plus little b cosine big B of x into a single trigonometric function y equals big A sine of the quantity big Bx plus big C.
So the first thing we want to do is we want to graph y equals sine x plus cosine x on a graphing calculator. And when we do that, we'll find certain values that we can plug into this equation to see if they are true, make an identity. So let's go to the graphing calculator. Okay, so I already have the equation on my calculator, and this is our window. As you can see, we'll go back to y equals, and then we'll graph it. And as you can see, it doesn't look like any sine curve or cosine curve that we can figure out. And we can actually do either sine or cosine, but in this case, because of the equation on the board, we're going to do sine. So what you would do is we're going to find some zeros. So I'm going to find the maximum. And then guess. Okay, so our maximum is 1.1442 on the board. So now we need to find the minimum. And there's our left bound. There's our right bound. Guess. So it's negative 1.4142. Sorry. Yes. Negative 1.4142. So as you can see in this equation that one's just the negative of the other, which means that we don't have any vertical translation, which is good. So when we would find, we can use these two to find the amplitude, which equals 1/2 the absolute value of the maximum minus the minimum. So we'll just plug in the equation. A equals 1/2 of 1.4142 minus the negative 1.4142. And just to figure out logically, when you would add these two together because they're both negatives, and it would just give you double this value. And then when you subtract it by 2, it will give you the same answer. And it's absolute value, so it is positive, which amplitude always is. So just using that reasoning, we have 1.4142 as our amplitude. So in this case, when you are subtracting a value from a negative, or subtracting a negative value from a positive value, you'll actually be adding them. And this will, because they're essentially the same value numerically without the negative sign, it's going to be double this. So you would add this up, you get double this value, 1.4142, and then by dividing it by 2, you would get this value again. So A equals 1.4142 as your amplitude, and because it's absolute value, it would be positive anyway.
Alright, so the next step is to find B, and 1 period is equal to 2 pi over B. So to solve for B, we just need to go 2 pi times the period. Our next step is to find the 0 to help us with B. So we're going to go second trace to find the 0. Left bound, then go right bound, guess, and our 0 is going to equal 5.49. So after we find the 0, one period of the graph is 5.49, and 2 pi is 6.28 over b. So to solve for b, we would multiply by 1 over 6.28, which would give us 1 over b is equal to 5.49 over 6.28. So b would equal 6.28 over 5.49, which would give us a b final answer of 1.14389.
Okay, so c is our phase shift. So to find our phase shift, we take the equation negative c over b is equal to our shift. So c is equal to shift times negative b. Okay, so to find our x, we're going to go to 0, our left bound here, and a right bound here, guess. Okay, so our x is going to equal a negative 0.7853. So we already have our b from this section, so we're going to plug it into our formula here. So negative c over our b value is going to equal our x that we just found. So it's negative c over 1.14389 is equal to negative 0.785398. So therefore c is equal to negative 0.785398 times a negative 1.14389. Okay, so C, we crunched it on the calculator. Our final answer is 0.898408, and that will be the phase shift.
So now we're going to compare the two graphs of y equals sine x plus cosine x and y equals a sine times bx plus c with the three values that we found already. So the equation is going to be y equals 1.4142 sine times 1.14389x plus 0.898408. And now we're going to plug this into the calculator and compare the graphs. And now you can see that we went to the y equals, and that's sine x plus cosine x for the first one. And for the second, 1.4142 sine times 1.14389x plus 0.898408. Hit graph, and as you can see that the second graph is not the same as the first, so now we have to prove it as an identity.
So now that we figured out that our approximation graph wasn't exactly like the first graph that we did, sine x plus cosine x, we need to prove or find an identity using this form that would be equivalent to this form. So we're going to take the right side because I see that I can use an additive formula. And this is a sine addition formula, so I'll just write out what I'm going to use first. Or the simple layout of it, sine of a plus b. And as you can see here, we have a value that would be equivalent to an a and a b is equal to the sine of a, the cosine of b plus the cosine of a times the sine of b. And we're going to use this kind of format put this, or to lay this out. A, B, and C are all constant. X is just a variable, so we're just going to lay it out as A times the entire quantity of sine Bx, which is our A, cosine C, plus cosine Bx sine C. Okay? And then we're just going to multiply it in individually. Now, I want to take a minute to say that we do have on both sides, we have a sine of bx and a cosine of bx. But the problem is that this equation, which we're trying to make this equation look like, does not have a sine c or a cosine c. But it does have an a and b. And what I'm going to try to do is make, when I multiply the big A in, make A cosine C and A sine C equivalent to B and equivalent to A, not respectively, but I will show that. So when I multiply it out, I'm going to put A cosine C times the quantity of sine Bx plus A sine C times the quantity of cosine Bx. Now we pretty much have these two quantities down, but I'm just going to go on a hunch and say that these two values this value needs to be equal to little a, this value needs to be equal to little b. So we're just going to write that out. Little a in this equation is equal to a cosine c, little b is equal to a sine c. And that's what we're going to represent it as thus far.